that will hopefully be landing on the moon, but it's going to take a while to get there. Blue Ghost will spend 25 days orbiting the Earth and performing system checks and gathering preliminary data with its 10 onboard scientific instruments, all of which have been provided by NASA under the administration's Commercial Lunar Payload Services. Basically, NASA provided some funding to Firefly, and in return, their stuff gets a ride to the moon. The mission has been titled Ghost Riders in the Sky. It's a great tune. After the 25-day Earth orbit shakedown period, Blue Ghost will fire up for a translunar injection burn, sending it on a 4-day journey to the orbit of the moon, where, again, it's going to hang out for a while and get the feel for the place. Another 16 days spent in orbit, and over this time, the lander will slowly lower its orbit until it's flying just 100 kilometers above the surface of the moon. Now, the fun part. 1 hour before landing, the main engine reignites to knock Blue Ghost out of orbit. As it coasts downward, the lander has a terrain relative navigation system that is going to be calculating altitude and rate of descent, while analyzing the surface to identify a suitable landing spot. The target area for this mission will be Mare Crisium, a low-lying volcanic region that is littered with impact craters. It's just north from the Sea of Tranquility where Neil and Buzz landed. It's also the site of 2 failed Soviet robotic landings and 1 successful Soviet mission that actually completed a robotic sample return from Mare Crisium. The small amount of material that the Soviets were able to get their hands on showed the presence of 0.1% water by mass in the volcanic soil. At 20 kilometers altitude, the lander will pitch over and make a final burn of the main engine, dropping velocity to 145 kilometers per hour and positioning itself over the selected touchdown zone. The final kilometer of the descent is handed off to the vehicle's 8 reaction control thrusters to ease down into a soft landing. That's what they're hoping for, at least, but when it comes to landing on the moon, many have tried and many have failed, particularly in the last years alone. Blue Ghost has a few major factors that are working in its favor. The physical design makes a lot of sense for achieving a stable touchdown. The lander is just 2 meters tall and it's 3.5 meters wide, so it's going to be very resistant to tipping over even if landing on uneven surfaces. So now what? Well, the Blue Ghost's maximum payload capacity to the moon is 150 kilograms, and that's been loaded out with 10 NASA payloads, my favorite of which being the Moon Vacuum. Lunar Planet Vac is designed to suck up dusty Regulus samples from the surface underneath the lander. So how do you make a vacuum work in an environment with no air though? A vacuum in a vacuum. You used compressed gas, so it's actually more like blowing the regolith into a canister inside the spacecraft. Another really cool experiment is going to be running as the lander touches down. This is the stereo cameras for lunar plume surface studies. It's going to take photos of the dust that's kicked up by the spacecraft's landing thrusters to measure how much material goes airborne and how it behaves once it's been disturbed. Moondust is very fine, very light, and it moves through an environment with no air and very little gravity. So once it gets into motion, there's not much that's going to slow it down. That could be a very large problem, and there is a worry that if we kick up too much dust by operating on the moon, we could trigger an infinite dust storm. In 1969, Apollo 12 landed on the moon just 150 meters away from a previous NASA lander called Surveyor 3. When the astronauts went over to investigate the condition of Surveyor 3, they found it was completely sand-blasted and pulverized by stray rocks that had been thrown out by the crew's lunar excursion module. Speaking of that dust, Blue Ghost is equipped with a new instrument called the Electrodynamic Dust Shield. It's supposed to prevent buildup on the equipment by using electrical currents to repel the dust particles. This technology will be critical if we want to build things like long-term solar panels, windows, or radiators on the moon. It can also be very useful for keeping the abrasive dust off of an astronaut's visor as they explore the moon, something that was a big problem for Apollo. This is the next generation lunar retroreflector. It's going to help us measure the distance between the Earth and the Moon down to a sub-millimeter accuracy. Basically, they're going to use this little mirror to reflect a laser beam down to a receiving station on the Earth. The Lunar Instrument for Subspace Thermal Exploration with Rapidity is a very long name for a drill that will penetrate 2 to 3 meters into the ground and show how heat flows through conduction below the moon's surface and the thermal changes between the different depths. And then we have the Lunar Magnotelluric Sounder. This is at the top of a mast that extends out from the top of the lander, and it's actually going to measure activity that is going on deep within the lunar mantle, as in about 2/3 of the way down to the moon's core. I think there are still a couple in there that I missed. It's really a lot of stuff. But then after all of that work is done over the course of 14 Earth days, Blue Ghost will capture images of the lunar sunset as its final mission, paying particular attention to how the lunar regolith reacts to the changes in sunlight. And then the lander will continue to operate for several hours in darkness until its batteries finally go dead. But wait, there's more. Japan's lunar lander may have launched side by side Blue Ghost, but it's taking a unique trip to the moon. In fact, the American mission will be long dead by the time Japan's entry even arrives. This is the Hakuto R lander, built by the private firm iSpace, and they actually tried to land one of these on a previous mission in 2023. A computer guidance error led to the vehicle running out of fuel at high altitude and smashing into the moon at a speed of over 100 meters per second. This is a do-over flight that has been named Resilience. Now that Resilience is in orbit around the Earth, it's beginning the process of a long, slow journey to the moon that will take a couple of months to complete. The goal of this approach to the moon is to use as little fuel as possible. The lander will actually be using a few gravity assist flybys of the Earth and the moon to reach its ultimate trajectory. So we've already seen the Hakuto R make one attempt to land on the moon. And that means we know its ability to reach lunar orbit and descend down most of the way to the surface is just fine. It's the last mile delivery that still needs to be proven, and they say the best way to learn is by failing, so hopefully iSpace has learned a lot from that first attempt. Assuming that Resilience makes it down in one